Today, my group consists of Aina Hassana, Nur Ashikin, Putri Nur Julia, Natasha, and me, Siti Nur Aisha, would like to present on research regarding analysis of passive bloodstain morphology across surface texture and drop height using deep learning published by Jomon et al. 2026. In this study, researchers analyzed passive bloodstain formed from vertically dropped goat blood on different surfaces by using deep learning models including custom convolutional neural network CNN and mobile net to classify bloodstain patterns based on the height of the blood drop. The aim of this study was to improve the accuracy and reliability of bloodstain pattern analysis in forensic investigation. The interpretation of bloodstain patterns can be affected by factors such as drop height, surface texture, porosity, and absorbency. These factors can change the size and shape of bloodstains, making forensic analysis more difficult. In addition, traditional bloodstain analysis mainly depends on manual observation and the experience of analysts, which may lead to human error and inconsistent results. Therefore, this study was conducted to examine the effects of drop height and different surfaces types on passive bloodstain patterns and to evaluate the use of deep learning models in improving the accuracy and consistency of bloodstain analysis.
The researchers used goat blood because its viscosity, surface tension, and clotting behavior are similar to human blood while avoiding ethical concerns. Blood droplets were released vertically, which is from 90-degree impact angle from three different heights, which is 20 cm, 40 cm, and 60 cm. Water droplets were also used as controls to compare the influence of fluid composition. The droplets were deposited on four different surfaces: chart paper, jute fabric, concrete, paper cups. Images of the bloodstain patterns were collected and analyzed using two deep learning models, custom CNN and mobile net. The classification performance of both models was evaluated using accuracy, precision, and recall.
After conducting the experiments, the researchers obtained several important findings regarding bloodstain formation and the performance of artificial intelligence. The results and discussion sections of this study presents three key findings. First, the researchers investigate how different surfaces influence bloodstain morphology. Next, they compared the performance of two deep learning models in classifying bloodstain patterns. And lastly, they examined on whether an AI model trained on one surface could accurately classify bloodstain on other surfaces. Let me ask you one question. If every drop of blood falls from exactly the same height, would every bloodstain look identical? Let's find out. The answer is no. Porous surfaces such as jute absorb more blood, making it less distinct. In contrast, smoother surfaces such as concrete or jellystone produce clearer stains with more visible satellite spatters. So, why does this happen?
Every bloodstain begins with the same blood drop. Once it impacts a surface, properties such as porosity, texture, and absorbency influence how the blood spreads. Consequently, different surfaces produce different bloodstain patterns even under the same experimental conditions. Interestingly, the researchers also compared blood with colored water. Surprisingly, both produce very similar stain shapes under vertical drops.
This suggests that, under controlled vertical drop conditions, the surface has a greater influence on stain morphology than the liquid itself.
Next, the result to which AI performed better. The research compared two different artificial intelligence models to determine which one could classify bloodstain impact height more accurately. Before I explain the result, I have already attached a simple short video to help you understand how a custom CNN works and mobile network. Please watch this video first as it will make the comparison easier to understand.
Last summer, my family and I visited Russia. Even though none of us could read Russian, we did not have any trouble in figuring our way out, all thanks to Google's real-time translation of Russian boards into English. This is just one of the several applications of neural networks. Neural networks form the base of deep learning, a subfield of machine learning where the algorithms are inspired by the structure of the human brain. Neural networks take in data, train themselves to recognize the patterns in this data, and then predict the outputs for a new set of similar data.
Okay, the first model custom CNN did not perform well. It memorized the training image instead of learning the characteristic of a bloodstain. As a result, when it analyzed new bloodstain image, it frequently made incorrect prediction.
So then, based on the slide, they show coefficient matrix of CNN. Notice that the model classified many different bloodstains into the same category. This indicates overfitting. Then, move to MobileNet. In contrast, MobileNet achieved much higher accuracy. This model have already learned general image feature before being trained with bloodstain image, allowing it to recognize pattern more effectively even with a relatively small dataset. Overall, MobileNet performed better because transfer learning reduced overfitting and improved bloodstain classification.
Next is result 3. Can one AI model analyze every surface? First, the researchers trained the MobileNet model using bloodstain image on the chart paper only. Then, they test the same model on the jute, concrete and paper cup. As you can see, the accuracy become much lower. The model only achieved 29.8% in jute, 3.9% on concrete and 18.5% on paper cup. This is because bloodstain look different on different surface. So, a model trained only on paper cannot recognize bloodstain on other surface very well. Then, the research trained a separate AI model for each surface. The accuracy improved a lot, especially on paper cup where it reached 99.9%. This shows that using a surface-specific AI model gives much better result than using one model for all surface.
There are three main novel findings in this study. First, the study demonstrated that artificial intelligence can accurately classify passive bloodstains according to their drop height, reducing reliance on subjective visual interpretation by forensic experts. Second, transfer learning with MobileNet outperformed a custom CNN model, making it a more effective approach when only a limited forensic dataset is available. Finally, the researchers found that bloodstain patterns are highly surface-dependent. This means that AI models should be trained using multiple surfaces or separate models, as real crime scenes involve a variety of materials such as wall, floors, clothing, and furniture. Overall, this study demonstrates that artificial intelligence has great potential to improve bloodstain pattern analysis. However, it also highlights that surface characteristics must be considered to ensure accurate and reliable forensic interpretation.
This study is important because it introduces artificial intelligence into forensic bloodstain analysis. Instead of relying solely on an examiner's visual judgment, investigators can use deep learning models to assist in determining the height from which blood droplets originated. This could improve the consistency, objectivity, and reliability of crime scene reconstruction. The researchers concluded that deep learning is a promising tool for bloodstain pattern analysis. MobileNet successfully classified bloodstain patterns produced from different drop heights, particularly when trained for specific surface types. Although bloodstain morphology varies with substrate properties, AI-assisted analysis can provide accurate and reproducible classifications.